Hi Rockridge, this is Mrs. Berger, and today we're going to do a lesson on factoring. We're going to first review a couple of the warm-up problems that you have to remind you how to do factoring as we did in Algebra 1, and then we're going to expand on that concept and increase our knowledge of how to factor different types of trinomials. So let's take a look at this warm-up. I'm not going to record myself doing all of the problems in the warm-up. I'm going to do a couple of different examples here and let you do the rest. But let's start with number 1. And see how we did this in Algebra 1 class. So if we were to factor this expression, x squared minus x minus 2, the first thing we always check for is a greatest common factor, or a GCF, a greatest common factor. I look here and I see a 1, a -1, a -2. I don't see a greatest common factor to pull out of any of these terms, to pull out of all three of these terms, and so therefore I don't have one. I don't have a greatest common factor, and I will launch into the steps I take to factor this this trinomial. So I need to find two numbers that multiply to -2 and add to -1. Remember that? So factors of -2, this number here, whose sum is -1, this number here. And if you recall, some of you did a diamond chart to sort of organize your thoughts, and you put the factors of up here and the sum is. So we try to think of two numbers that multiply to -2 and add to -1. And you're probably at least thinking, well, it's got to be some combination of 2 and 1, right? 2 times 1. And I need to have a -1 after the summing, so I need to make this 2 the negative. If I have -2 times 1, I get -2. And if I have -2 plus 1, I get -1. And so therefore the factored form is x minus 2 and x plus 1. That is the factored form of our original expression. If we wanted to check our work, we would just take first times first, outer times outer, inner times inner, and last times last, and we would get back to the original that we had to prove that we have factored correctly. So hopefully this is ringing some bells. Let me do two more. I'd like to skip number 2. Let me go to number 3. And let's see, do we have something that is the greatest common factor of these two terms? And we do. We have a couple of things that are common to both of these. We see a -4 is common to both of them, and we see an x is common to both of them. And so we need to factor a -4x out of each of these terms. And the way we do that is we divide each of these terms by -4x. Divide each term by -4x. And so the left behind goes in here. -4x squared divided by -4x leaves just x behind. 36xy divided by -4x will leave behind a -9, sorry about that. A -9y. And I look in here and I see if there's anything else that I can factor, as I did in number 1, and there is not. So this is the final factored version of that expression. We've done all we can do for that one. Now let's combine those two skills in number 4. Let's check and see if we have a greatest common factor that can be taken out. Is there something common to all three of these? And you should be looking at that. You should at least see that there's a 3 common to all of them. But then you should also see that there is an n, as in Nancy. There's an n here that's common to all of them as well. So that is the greatest common factor to all three of these. And if you were to divide 3n into each of these, you would see that you leave behind an n squared plus 2n minus 3. Alright, so that has taken out the greatest common factor. Then we need to look and see if we need to employ our skills from number 1. And we do in fact see a trinomial here that we can look for factors of -3, things that multiply to -3, whose sum is +2, things that add together to be 2. And so if we need a visual representation, we can say -3 and 2 here. What multiplies to -3 and adds to 2? And hopefully you're thinking, well, it's got to be some combo of 3 and 1, right? It's got to be something like that. And if I need to end up with a +2 That means I need this to be negative. Let's check. 3 times -1 is -3. 3 plus -1 is +2. So I have chosen wisely. So that means I have an n plus 3 and an n minus 1. But don't forget, we need this 3n to come back and make its curtain call, make its final appearance in our answer, because we did factor it out. So that is one of the factors. So our final factored form of number 4 is the 3n, and then an n plus 3, and an n minus 1. So if you need to pause the video and practice the rest of your practices and check them against the key, go ahead. But hopefully this is ringing some bells from Algebra 1. Now, the Algebra 2 material today, we're going to continue to factor. And again, let's remember what factoring is. It's breaking up the expressions that were given into the little pieces that were originally there, that were originally multiplied together to create them. If you'd like to think of it as we're doing a reverse form of FOIL. We're reverse foiling, right? Or reverse distributing. We're going in reverse. Instead of multiplying first times first, outer times outer, inner times inner, last times last, we're undoing that work by factoring. So today we'll be presented with expressions in this form, ax squared plus bx plus c. And those a's and b's and c's are going to be presented to us as constants, as numbers. These are called quadratic trinomials. This is called a quadratic trinomial, and you probably remember this term from before. It's 3 terms, right? Trinomial, 3 terms. The first term is called the quadratic term. That's the one with the x squared. The second term is the linear term. That's just the x. And the third is the constant, and if you would like to think about it this way, the constant is being multiplied by x to the 0 power, which of course is just 1, right? The first step in factoring is always to try to get out a GCF. Always start with looking for a GCF. When you do that, you may need to pull out not only a number, but also a variable, right? Remember from number 4 in the warm-up? So make sure you get the greatest common factor, including numbers and variables, before you go any further for factoring. Today we're going to factor quadratics where the coefficient of the quadratic term, the a, is not equal to 1. It's not that invisible 1 that we've been seeing. We're going to show you 4 different ways to factor. After I show you the 4 different methods, I'm actually going to default back to the factors of whose sum is method as the standard method for the rest of the examples. Alright, so let's take a look at the first one in the group practice. Number 1, and I will show you 2 different ways to do number 1, and then a third and fourth way to do number 2, and then you can choose what your favorite is, but I will continue with the FOSI method. So let's start with the FOSI method, FOSI meaning FO, factors of whose sum is. Now number 1, let's look and see if there's a greatest common factor first. That should always be our first step. I look and look and look. I don't find a greatest common factor here, so I launch right into my steps. I need to find factors of 3 times -6. So remember before we had just an invisible number 1 here, but now we don't. We have a 3 here. So we need to multiply 3 times the -6. So factors of -18 whose sum is -7. Okay? If you need the visual representation of the diamond, factors of -18 whose sum is -7. And hopefully you're thinking and thinking and you're thinking, I'll bet it's some combination of 9 and 2. I'm going to need to make the 9 a negative and the 2 a positive. Now typically in the old world, before we had this problem with the 3 out here, we would just go ahead and build an x minus 9 and an x plus 2. But we can't do that this time. We need to take one extra step. I like to make a little t-chart with a -9 on the bottom and a 2. That's what I worked so hard to get, the -9 and the 2. And on the top of that t-chart gets a 3 and a 3. So this always goes to the top of the t-chart. And this t-chart is just a tool I use during factoring. There's no real math going on here. This is just to help me set up my factors. What I do with the t-chart is I look to see if there's something I can reduce. If there's something common to 3 and 2, there is not. Or if there's something common to 3 and -9 that I can reduce. And there is with this side of the chart. I can take a 3 out of 3 and make it a 1. And I could take a 3, add a -9, and make it a -3. So from this table, I now build my factors. I now build my factors by saying the first factor is 1x minus 3, or just x minus 3. My second factor is 3x plus 2. Okay, so the top of whatever's left on the chart is your x coefficient in your term, in your factor, and then the bottom of the chart is your constant in your factor. Okay, so your final factored solution is x minus 3 and 3x plus 2. And you could always check that by refoiling, right? You can refoil this and see if you get back to the beginning. All right, so that's what we call the foci method. Now I'm going to use the same example and show you the slide and divide method. Slide and divide. In slide and divide, it's somewhat similar work. We take this 3 times the -6 and we kind of rebuild our problem. I'll write it in black here. We rebuild our problem. So we rebuild it as x squared minus 7x minus 18. Okay, and that again, that -18 came from 3 times -6. And then we think, what multiplies to -18 and adds to -7? Well, we already know that it's some version of 9 and 2, right? It's an x minus a 9 and an x plus a 2. Now, the slide and divide method needs you to divide by this 3. Okay, whatever this number was here, you now need to divide these numbers here by 3. So to divide this by 3 and divide this by 3. This original 3 that we had here. What happens then is we see that 9 divided by 3 turns into a 3. And then 2 divided by 3, that doesn't reduce. If it doesn't reduce, it needs to go back and become the coefficient here. So our final build on this is 3x plus 2 and x minus 3, which of course matches what we had over here. Okay, so that is slide and divide, and shows you that you take the first times the last and put it here, and then you divide by this coefficient. After you come up with these two multipliers here, divide by that coefficient, and then when you have a leftover here, you move it back to the front. Alright, so we've done foci and slide and divide. Let me show you two more methods. We'll use a new example here. We'll use example 2 to show you split the middle term. Okay, so split the middle term is just like it sounds. Split middle. We look at what we're given here. First of all, do we have a greatest common factor? No, we do not, so we can move on here. We try to find factors of 20, so factors of the 20, 2 times the 10, that add to, or that sum, whose sum is the -9 in the middle. And when we think of what those things are, what we come up with is a -5 and a -4. So after thinking about what that is, things that multiply to 20 and add to -9, when we come up with that as a -5 and a -4, we now split this -9r into those two things. So we rewrite it as 2r squared minus 4r minus 5r plus 10. So we just split this middle term, right? Now we kind of group them together and take a GCF, take a greatest common factor out of each. So out of this one we pull a 2r and leave behind an r minus 2. And out of this one we can find that we have a -5 common to both. and we leave behind an r minus 2. To build our final factors with this method, we take the one that is common, r minus 2, and we take the leftovers, 2r minus 5. 2r minus 5. That is the factored form of our original. And again, you can check it by refoiling this back out and seeing if you get back to what we had in the beginning. So that's called splitting the middle term. That's another method that you can use. And then our last method is called guess and check. Okay, so we'll just call this guess and check. So we'll use this example still. When we look at this and we think of the factored form of this, we think, well, we know that if something was FOILed originally to make this thing, this first term here, first times first, must have been 2r and r, right? Because there's only so many things that can multiply to be 2. Positive 1 and positive 2. So we know 2r and r had to be the beginning of these two factors when they were FOILed together. Now we think, all right, this last term, this last set of terms, the last times the lasts, needed to have been multiplied together to get 10. So we start thinking, what are factors of 10? Well, we have positive and negative 10, 1, we've got positive and negative 5 and 2. Those are the only combos that we have to work with, right? So here, we've got to have some version of 10 and 1 or 5 and 2. This is what I have to work with. And I need to make whatever that combo is, I need to make it match the middle term. Make it match the middle term of negative 9, right? So basically, the guess and check method, and there's a little more educated guessing going on than just straight up guessing, but the educated guess and check method has you try and check 10 and 1, positive 10, negative 1, negative 10, positive 1, positive 5, negative 2, negative 5, positive 2. Go back and forth to find out what combination is going to get you what you need. And eventually, you should get to the fact that if we use a negative 5 and a negative 2, that's going to multiply and get us our positive 10. And if we were to refoil this out, 2r times r is 2r squared. 2r times negative 2 is negative 4r. And a negative 5r gets us our negative 9r. And sure enough, this method has netted us the same answer as the purple, the splitting the middle term. Okay? Alright, for the rest of the practice, I am going to default back to foci. If you prefer slide and divide, or splitting the middle term, or guess and check, you should use that. If you like a particular method, that is what you should be practicing with. But for the rest of the notes, I will be going through the foci method. Okay? So for number 3, I need to first look for a GCF. I don't see one. 5, 16, and 3 don't have one. And so I start thinking, alright, what are factors of 5 times 3, which is 15, whose sum is 16? And I should immediately be thinking, well, it's got to be a combination of 1 and 15, right? It's got to be a combination of 1 and 15. And for this particular one, it's 1 and 15. It's positive 1 and positive 15. If I was to multiply them together, I would get 15. If I was to add them together, I would get 16. The top of my t-chart should get the 5 that was the original beginning of this. Okay? Now I need to check and see if there is some reduction that can be done. There's no reduction here. There's nothing I can take out of these two. But out of the 5 and the 15, I can take a 5 out of each one of those. 5 divided by 5 is 1. 15 divided by 5 is 3. And so I build my factors as 5x plus 1 and x plus 3. Don't forget, this top term is always the one that goes with the x. So that's the factored form of number 3. Number 4, I will again check to see if there is a greatest common factor. 3, positive 1, and negative 10 do not have one. So I find factors of negative 30, whose sum is positive 1. My t-chart will get a 3, so I can automatically fill that in. Now let me think here. What are things that multiply to negative 30 and add to 1? It's probably some version of 6 and 5, right? 6 times 5 is 30, and I need something to be a difference of 1. I need it to be a positive 1, so I'm going to give the 5 the negative sign, because 6 times negative 5 is negative 30, and 6 plus negative 5 is positive 1. Now I need to look and check to see if that can reduce. I can always reduce. There's nothing to reduce here, but I can pull a 3 out of 3 here and a 3 out of 6 here. Now I can build my factors, k plus 2 and 3k minus 5. And I can always check this by refoiling it back out to see if I get back to the beginning. Number 5, I need to check to see if there's a greatest common factor. There is not a greatest common factor here. 10, negative 29, and negative 3 don't have one. So I'm trying to look for factors of negative 30, 10 times negative 3, whose sum is negative 29. I can build my t-chart, and I can already populate the top with a positive 10 on each side, because that's always going to go there. Now, what multiplies to negative 30 and adds to negative 29? Well, it's probably some version of 30 and 1, right? And I need it to be a negative 29, so the negative 30 gets the negative sign, and the 1 gets the positive sign. I can reduce, not the 10 and the 1, but the 10 and the negative 30. Always keep your negative sign with the number that it started with. So always leave that on the bottom there. So I get it down to a 1 and a negative 3. And then I build my factors. m minus 3 and 10m plus 1. It doesn't matter which order I put them in. Look again for a greatest common factor. I don't find one. I ask myself, what are factors of 40, 8 times 5, whose sum is 22? And I can build my t-chart while I'm thinking. Things that multiply to 40 and add to 22. Well, I'm immediately thinking it's got to be some version of 20 and 2. 20 times 2 is 40. 20 plus 2 is 22. I can leave both of their signs positive. Let's do some reducing. And actually, we can reduce both sides. We can reduce the right-hand side by 2. So we go 4 and 1. Over here, we can reduce both sides by 4 instead of 2. We can reduce this by 4 and make it a 2, and this by 4 and make it a 5. Sometimes that happens. Sometimes we can do both sides. We can always do at least one side. So now we can build 2r plus 5 and 4r plus 1. Number 7, I will look for a greatest common factor. And finally, I will finally find a greatest common factor. There is something common to all of these. It is 2. So we must first pull that out. Pull a 2 out and leave behind 3r squared plus 2r minus 21. Now I can ask myself, what are factors of negative 63 whose sum is positive 2? I can build my t-chart while I'm thinking, and remember the top of the t-chart gets the 3. It does not get the 6. That 2 took that 6 away. So this is the 3. This is the top of the t-chart now. Now hopefully in the time that we've sat here thinking, we've begun to say, wait, isn't 9 times 7 63? Yes, it is. And I need to have a difference of 2. So if I have that, I need a positive 2 to come out. So I need this 7 to be the negative. 9 times negative 7 is negative 63. 9 minus 7 is 2. Now I need to look and see about reduction. There's nothing to reduce here, but there is here. This reduces to 1 and 3. So my final factored solution is r plus 3 and 3r minus 7. And don't forget to make its final curtain call. This 2 needs to come back in the final solution. So do not forget about your GCF in your final factored solution. Number 8 also has a greatest common factor. It has a greatest common factor of 5. Factor out the 5 first before you do anything else. And you'll leave behind 5v squared minus 18v minus 8. Now I need to find factors of negative 40, the 5 times the negative 8, whose sum is negative 18. I can build my t-chart while I'm thinking. It gets populated with this 5 on top. And now let me think of what two numbers multiply to negative 40 and add to negative 18. Hopefully you've thought of 2 and 20 as your candidates. 2 and 20. Somebody has to be negative. Since this is a negative 18, I need the 20 to be the negative. So 2 times negative 20 is negative 40, and 2 plus negative 20 is negative 18. Now I go through and look to see if there's something to be reduced. 5 and 2, nothing to be reduced. 5 and negative 20 can be reduced to 1 and negative 4. So I build my factors as 5v plus 2 and 1v minus 4. Don't forget to bring 5 back in for its final curtain call. Don't forget him in the end. Okay. And again, these can be in different order if you came up with those numbers in a different order. Alright, number 9, let's look for a greatest common factor. I have found one. I see a 2. That's the greatest common factor here. So let's factor that out first. 4n squared minus 8n plus 3. Now let's do my FOSI work. What are factors of 12 whose sum is negative 8? I'll build my t-chart while I'm thinking. Things that multiply to 12 and add to 8, I'm immediately thinking, well, there's got to be some version of 6 and 2. 6 times 2 and 6 plus 2. Well, I need it to add to be negative, so both of these need to be negative. Negative 6 times negative 2 gets me a positive 12. Negative 6 plus negative 2 gives me a negative 8. Both sides can be reduced. So the left can be reduced to 2 and negative 3, and the right can be reduced to 2 and negative 1. So our factors are 2n minus 3 and 2n minus 1. Don't forget your greatest common factor for its final bow. And there's your factored solution. Number 10, when I look for a greatest common factor, I can't stop at 2. I need to go as high as 4. I need to find the G is for greatest. I need to find the greatest common factor, and that is a 4. So that leaves behind 10x squared minus 7x minus 12. Now I'm looking in here, and I'm trying to find factors of negative 120. Whose sum is negative 7. I can build my t-chart while I'm thinking. This one may take a little while for you to think about, because 120 is such a big number, but if you noodle through it long enough, you should come to the conclusion that you can multiply 15 and 8. 15 and 8 multiplied together gives you 120. And now I need them to sum to negative 7. So I need this 15 to be negative, and I need the 8 to be positive. Okay, some of these will take you a little longer to noodle through. Have heart, you will get there. Now let's look at the left and the right and see what we can reduce. On the right, we can reduce this to 5 and 4. On the left, we can reduce this to 2 and negative 3. So we can build our factors. 2x minus 3, 5x plus 4. Do not forget about your greatest common factor in your final answer. Alright, remember when we said it's not just numbers we need to look at when we're searching for a greatest common factor. So that's going to come true here now in number 11. Number 11, you can factor more than just a greatest common factor number. Notice that there is an x squared that is common to all of these. So we can factor out a 4x squared from all of these. Let's see what's left behind. If I divide each term by 4x squared, I'm left with 4x squared plus 15x minus 25. Alright, now I can start using my tool of factors of whose sum is. I need to find factors of negative 100 whose sum is positive 15. So I'll build my t-chart, fill it in with the 4. That always comes from right here. Now things that multiply to negative 100 and add to 15. Hopefully you're thinking, well, I know 20 and 5 multiply to 100, and I need it to end up positive 15. So the 20 needs to be positive, and the 5 needs to be negative. Now let's reduce where we can. Nothing's happening here, but we can take a 4 out of each of these and reduce there. So we should be left with an x plus 5 and a 4x minus 5. Don't forget that we factored out a 4x squared to begin with, so that our final answer is this whole thing. It could possibly be in a different order, and that's fine. But those are the factors of our original. Again, in number 12, we don't just have numbers that are common to all of these, we have letters as well. So let's factor out something that's common to all of them. I see a negative 3 common to all of them, and I also see an n common to all of them. This one's a little bit tricky. Let's see what happens here. 4m squared plus 4 mn minus 15n squared. So this is an interesting one. This one you may not, it may not help to use foci. You might be doing the guess and check method, because you need to build factors that have n's over here and m's in the beginning, right? So you may need to do guess and check for this one. We need these things to multiply, this middle to be multiplied to the negative 60 and adding to the 4 for our t-chart if we were going to do a t-chart. Let's start trying things that multiply to 4. Let's try a 2 and a 2. Okay, let's try a 2 and a 2. If we have 2m, we'll get our 4m squared. And let's try and see if we can find things that multiply to 15. Usually we end up with a 5 and a 3 with the 15s, right? It's probably not 1 and 15. Now let's start playing with the signs here. What kind of signs can we use to make this work for us? These are obviously positive, but if I multiply the 2m and this 3n, I'll get a 6mn, and this is a 10mn. So I probably need this 10mn to be a positive, so that I can end up with a positive 4. And I need this 2m times 3n to be negative, so that I'm taking the 10 of these minus the 6 of them. Okay? And again, if you have scribble work that you'd like to do for the guess and check method, that's fine. But playing with the numbers and the signs until you get to where you need to go is how that method works. And don't forget, we factored out a negative 3n in the beginning, so that needs to come back in our final answer. Okay? So those are our notes for today. Go ahead and try your independent practice and let me know if you have any questions.